Beautiful. Beautiful. Okay, ears, eyes. About 3 of these I want to go over. Okay. This one was a multiple choice question, and 11% of you guys got it right the first time. So I cannot emphasize enough, guys. Not only do you need to know which one's right, but you need to know why the other ones are wrong. And so let's read this question because it's obvious that the other 4 are wrong. But I want to make sure you see the word that makes it wrong. So we did a Gallup poll. 28% of American adults expect to inherit money or valuable possessions. In the poll, 28% expect to inherit money or valuable possessions from a relative. The poll's margin of error was plus or minus 3. So we have a p-hat of 0.28, add 0.03, subtract 0.03. That gives me an interval. We have a 95% confidence interval. Question, or part A says, the poll used a method that gets an answer within 3% of the truth about the population 95% of the time. I don't dislike that. I'm not too sure I like that one. But again, let's read through the rest of these. The percent of all adults who expect inheritance must be between 0.25 and 0.31. It doesn't have to be. It doesn't have to be. That was just one sample we did, and we found that one interval. But we may have missed it, right? It says must be. Could be, that would have been right. Next one. The Gallup poll takes another poll in this issue. The result of the second poll will lie between 0.25 and 0.31. No, doesn't have to, because we're going to get a different p-hat. If we get a different p-hat, we're probably going to get a different interval. Okay? There's a 95% chance, I don't like that one already, that the percent of all adults who expect to inherit is between 0.25 and 0.31, and that's the incorrect one. It has nothing to do with probability for that 95% when I'm in. And then the last one, which probably is the one that you guys hit first, Gallup can be 95% confident that between here and here of the sample. No. 100% that the sample's in there, because the sample's dead on in the middle. If that said population, that would have been right. So the only one that has to be right is A. And that's interpreting the level. If you did this over and over and over again, 95% of the time, or of the intervals, used a method that gets an answer within 3% of the truth 95% of the time. In other words, if I did it a whole bunch of times, 95% of those. Probably me leading you to believe that 95% is not a probability. And so when you saw the 95% of the time, you probably took that one off. But I want you to understand that the other 4 are definitely wrong. Definitely wrong. Next one I want to go to, we changed quite a bit from here, but again, I want to make sure. Quality control, take a random sample of 25. Of the bags inspected, 3 had too much salt. That's the successes or the failures, 3. If there's 3 successes, there must be 22 failures. The large counts condition is not achieved because n times p is equal to 3, which is less than 10, and that's a true statement. We have to have the large counts, and it says it must be greater than 10. Random is not met. It says random sample. All conditions were met. Large counts condition is not met because n times 1 minus p is less than 30. I don't care about 30 with proportions. I care about 30 with means, not proportions. Proportions is 10. Proportions is 10. 10% condition is not met because the sample size of 50 is not greater than, we want our sample to be less than 10%, not greater than 10%. So again, these things you want to make sure that we know, okay? I don't want little uh-ohs happening from those things. This one, again, we're at 42%, so about half of you guys, just under. Tanya wants to estimate the proportion of her school senior that plan to attend prom. She interviews an SRS of 50 of the 750 seniors in her school and finds that 36 plan to go to the prom. Identify the population and the parameter. All seniors at Tanya's high school. that is the population because that's the only sample I took it from. The 50 seniors for sure is not the population. That's the sample. All seniors at Tanya's high school. All high school seniors, no, she just took it from her high school. And then the 50 seniors, that knocks that one out. And then the parameter is the true proportion of all seniors who plan to attend the prom. Not the 36 out of the 50. That's not a parameter, that's a sample. Not the 36 out of the 50. The true proportion of all high school seniors in the United States. And that one's the wrong because we didn't take a sample from the United States. The true proportion of all seniors who plan to attend the prom. And that was wrong because the population said 50 seniors. Y'all okay? Any other question that gave you a little bit of issues or something that you want to make sure that you know? Anything at all? Anything. Our plan is to go over 8.3 today. I will go over it not really fast, not really slow. It's going to be pretty quick because it's a repeat. Is a repeat. And then chapter 10 is a repeat. Okay? So I tell you the differences today. Differences. Here we go. 8.3. 8.3. I forgot to turn your homework on. Dang it. Okay. Many a times we're interested in the difference between populations. We talked a little bit about this in 8.1 when we had the girls' shoes and the boys' shoes. We didn't care how many shoes the girls have. We didn't care how many shoes the boys had. We were interested in the difference. Did the girls have more? Did they have about the same? Did they have less? Okay? Some people think that duct tape can fix anything. That's the old saying. If you can't fix it, just duck it. Okay? Even remove warts. They say you can put duct tape on warts, they will get removed because it's not getting any air. Investigators at the Army Medical Center tested using duct tape to remove warts versus the more traditional freezing method. Freezing normally is what they will end up doing to try to remove warts. Suppose that the duct tape was successful in removing 50% of the 123 warts, and the traditional was successful in removing 60%. Good enough with that? So we kind of have two different samples. We have a sample that we use for duct tape, and we have a sample that we used for the freezing. 60% success, 50% success. If you guys can remember the sampling distribution of p hat 1 minus p hat 2, let's talk about it. Mu, whoops, dadgummit. Here I am thinking I'm all ready to go. Turn it on. Now then, go back to slideshow. Now hit, thanks. Hit that button, this button. Okay, so the sampling distribution of p hat 1 minus p hat 2, mu of p hat 1 minus p hat 2 is equal to, we got, normally we would say P1 minus P2, right? We don't have P's, all we have are P hats. All we have are P hats. So this can't be true because I don't have mu and I don't have, I shouldn't say, yeah, those were pat. I don't have P hats, right? I don't have P's. But we also know that the standard deviation of p hat 1 minus p hat 2 was that really, really, really big square root formula, right? Where you had p1 minus p over n plus p1 minus p over n, right? And then we also know that the sampling distribution was approximately normal. If this one was normal and this one was normal, the difference had to be normal. Just kind of recall that. Good. Happy, happy, joy, joy. Let's go right into my formula. Let's go right into my formula. Statistics going to be in words. Your statistic for this is going to be p hat 1 minus p hat 2. I don't know if the duct tape was 1 and the freezing was 2, or the freezing was 1 and the duct tape was 2. it won't matter as long as you have things labeled. I typically don't do 1 and 2. I would have done like D and F. D for duct tape and F for freezing. Or I could have put F here and D. You don't have to use 1s and 2s. But that's what the statistic's going to be. Because we're always going to be concerned about the difference. We don't ever care about the sum of the two. All we care about is the difference. Okay? Plus or minus. The critical value is still going to be Z. You still find it the exact same way that we did on Friday. Inverse norm, center. I remembered that I wrote a program. If you don't have center, I wrote a program that will find the critical value for you. I'll show you if you want it. And then the standard error. This is different for 2 samples than it is for 1 sample. 1 sample, it was p hat, 1 minus p hat over n, square rooted. If it's 2 sample, it's still going to be p hat 1 minus p hat 1 over n1. But remember what we do with standard deviations or standard errors. We always add the variance. And so this is going to be p hat 2, 1 minus p hat 2 over n2. And all of this is radicaled. All of that is radicaled. Soak that up, take that up. I hope you recognize really quickly that there's not a whole lot of difference between what we did today and what we're going to do, or what we did Friday is what we're going to do today. We have 2 samples, and so we got a difference of 2, and we got 2 here, but we still have the Z. Okay, take your time, write it down, make sure you can see it. Remember that they put the star here. You don't have to put the star. AP will show the star there. Okay? Just kind of remember that. Pencil, 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 pencil. Happy, happy, joy, joy. Here we go. There's p hat 1 minus p hat 2. There's Z star, and there's that. That formula is on your formula sheet. We talked about that the other day, but I do want to show you again just so you can make sure. Formula sheet complete. Please open. So fast. Come on, there we go. So fast. Confidence interval statistic plus or minus critical value standard error statistic. You got to know what that is. It's either going to be p hat or p hat 1 minus p hat 2. That's going to be Z, and that's either going to be here if it's 1 sample, here if it's 2 sample. Don't use this down here. That says when P1 equals P2. We don't even know what P1 or P2 is. So P1 is not equal to P2 because I don't even know what it is, so I will not use this, I will use this. This looks just like this, except this one has hats, this one does not. Because in this one, we knew what the population was, and this one we do not. Okay, so it's on your formula sheet. Use it if you need it. Use it if you need it. Easy peasy so far. Pencil, pencil, pencils. Got a couple pencils up here. Any questions? Any questions? Any questions? Any questions? Let's go back. Let's go back. We're good. You two girls good? They're good? Okay. Everybody else? Psh, click. Conditions. Huh? Anybody got a random guess as to how many conditions there are? 3. Anybody want to take a wild guess of what one of them might be? Random sample? Not a random sample. We need 2. random samples. We need 2 random samples. And what they really want us to emphasize, guys, is this word right here. They need to be independent. They need to be independent. 2 independent random samples. 2 independent random samples. Or we've got 2 groups that we're randomly selecting from, or that we are randomly selecting using. Two independent random samples. How am I going to know if it's 2 or if it's 1? Y'all can kind of see that silly question, right? I mean, it's going to be really obvious if I want to know what the difference is or I want to know what the population is. 10%. They both have to be less than 10% of the population. They both have to be less than 10% of the population. Both samples need to be less than 10% of the population. So we have randomness, we have the 10% condition. They both need to be less than 10% of the population. Both. Less than, not greater than, not greater than, less than 10% of the population. And the last condition, they both have to fit large counts. They both have to fit large counts. So n times p hat 1, n times 1 minus p hat 1. Successes, failures. n2 times p hat 2, n2 1 minus p hat 2. Successes, failures. If you want to say all 4 of those have to be greater than 10, all 4 of those have to be greater than 10, both samples must be large enough to assume approximately normal. Both have to be large enough to assume approximate normal. So n times p, n times 1 minus p, n times p, n times 1 minus p. I hope you can understand the importance of what Friday was, because I told you it's just a repeat. It's just going to take you twice as long to do it now. Maybe not twice as long, probably 1.5 times as long. The z-score is still the same, on the same formula, just different. It's just a minor tweak to it. Minor tweak to it. Okay. Get these 3 conditions down. Get them down, because then I got to throw a little curveball to you that I haven't thrown you yet. Just a little curveball that I got to throw at you guys. So make sure you get these down. Everybody okay? Ready? All right. In the event that I am doing an experiment like the warts, where I take a random sample and I do something to those people or those things. Y'all okay with what I'm saying? If I'm just finding out information, I don't worry about this. But when I do an experiment, when I'm not putting them in the population, we don't check the 10% condition, because you're using all of the sample. You're not putting them back into the population. You're not putting them back into the population. You're using all of them. You're not selecting one person and doing something to them and then putting them back in and then selecting another person. Go with me what I'm saying? Once I take my random sample, I'm doing something to all of them, which I know is a little confusing because when I even do a random sample, I'm doing a random sample and I'm finding something about them, but I'm not doing it as a group. I'm kind of doing it one at a time. Right? I'm finding out how many siblings you have. I put you back in the population. I'm not going to choose you again, but I might. But that's why the 10% is. The chances of me selecting you again is really, really, really small. If you check it and you're not supposed to, they're going to ding you. If you check it and you're not supposed to, they're going to ding you. If you don't check it and you're supposed to, they're going to ding you. So the best way that I can tell you is if it's an experiment, if you're using them all, don't check it. Don't check it. It happens more with 2 samples than it does with 1 sample. Very few times does 1 sample it happen. It happens more with 2 samples than the 1 sample. Hopefully we get through a couple of more examples of this and this will make more sense to you. Okay? The best way I can tell you, and it took me a while to get this down because they just added that 2 years ago, 3 years ago now, I think. This book. I think it's 3 years ago. If it's an experiment, don't check the 10%. Bless. Click, 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 click. The random and the large counts got to get checked every time. You got to check those. That's a no-brainer. That's a no-brainer. Those you have to check and verify. Don't just check it and verify it. Okay. Any questions? Interpretation of the confidence interval? We are 95% confident that the, careful, true difference in populations. Okay? We are 95% confident that the interval from blank to blank captures the true difference. Make sure, guys, little bitty things. Make sure we refer to the population and make sure we're talking about the difference. Make sure we're talking about the difference. I'm going to give you something today that should help you with this statement. Make sure we're talking about the population. You've got to reference that difference. You've got to reference the population. We are 95% confident that the interval from here to here captures. What did we capture? What did we, if it's 2 samples, we capture the true difference in proportions. In 10.1, we are 95% confident that the interval from here to here will capture the true mean. In 10.2, we are 95% confident the interval from here to here will capture the true mean difference. Yippee, yippee, yo. Question? Yippee! It'll be cold this week. Finally. Andrew, is it your birthday today? Oh, happy birthday.
Appreciate it.
You're so welcome. It's nobody else's. No, wait, was it? Did we do the birthday thing in here, in this class? Or was that B days? That was B days. You have any idea what I'm talking about? It says birthday thing? Sorry. Side note, different note. Has nothing to do with this. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 cats. 28 if you include me. The chances that 2 people in this classroom share a birth date. Chances that 2 people in this classroom out of the 28 students with the 365 days. High, low, medium. It's way above 50. It's way above 50. It's almost 70. With 28. 28 maybe even closer to 80. 72, 73, somewhere in there, I think, though. But 2 people in this classroom share a birth date. And I don't even know. You put 366 people in a room, guaranteed that 2 will share. Yeah, guaranteed. I think it's if you put 48. I think 48 is like almost a 99% chance. I think, going off memory. Something interesting. We did it on B days because we had an extra B day. January birthdays, raise your hand. Date. What was what's today? 12th? Well, that was a good chance too. Dang it. February birthdays. Oh, hit me.
14, 29.
Dang it. March. Uh-oh. Are you telling the truth? I had 1 year I had a fart knockers tell me the same thing. 7. Oh yeah. I'm kidding, I'm lying. It's called the birthday paradox. Don't do it now, but look it up sometime. It's interesting. Our minds think linearly. Our minds think linearly, but it becomes exponentiated, right? Because you're not just trying to share it with one person. It's 1 out of the 28, and the other 28 could, and the other, so it just becomes exponentiated. Anyway, it's an interesting little paradox that makes our mind think. Okay, y'all okay with the statement? Here we go. Oh, let me interpret the level. Interpret the level, right? If we did this many, many times in repeated sampling in the long run, over and over again, right? I told you guys there's a bunch of ways to say that. 95% of the confidence intervals produced. Of the intervals. I told you guys, I don't think there's any other way. You got to have that of the intervals. Okay? Oh. I haven't learned how to get out of this yet. There we go. Of the intervals will capture the true difference. So again, little bitty things are going to separate our A's and our B's and our B's and our C's and our C's and the D's. But I talked to you about this test, and pretty much it's either an A or an F for the most part. There weren't a whole lot of C's. This year, I'm hoping there's no F's because I'm beating in your head pretty much what the test is. So make sure we talk about the difference when it's 2 samples. Make sure we talk about the difference. Make sure it still represents the population. Okay, make sure it still represents the population. Those are just the little bitty things that get us every once in a while, right? Sometimes we reference a sample when we're not supposed to. Should refer to the population. In my, where are we at? 15 years of doing stats, I think I've had 4 classes that did not have somebody with the same birthday. I think I've had 4. But one time there was only 17 kids in the class. So that probability drops quite a bit. It happened one time this year because there's only 18 kids in that class. Anyway, one year I had twins in the class, so that kind of blew that one out of the water. Y'all okay with statements? Here we go. Full-blown problem. Maybe one like you're going to see Friday. Test Friday. Test Friday. Maybe one like you're going to see Friday. Very, very, very similar to this. Except I bet it has Cheez-Its in it. A Harris Interactive Survey asked an independent random samples. There's your condition. Of adults from the U.S. and Germany, which would make sense. If you got a group from the U.S. and a group from Germany, they're probably independent. About the importance of brand names when buying clothes. Of the 2309 U.S. adults surveyed, 26% said brand names were important, compared with 22% of the 1058 German adults surveyed. Let P sub U equal the true proportion of U.S. adults who think brand names are important when buying clothes, and P sub G represent the true proportion of all German adults who think brand names are important when buying clothes. Check if the conditions are met. 2, independent, SRS 2309 US 1058 Germans. Good enough. Good enough. Would I like to be a little bit more specific? That's good enough. SRS check? Nope. Independent SRS? 2 independent SRS? Tell me what the 2 are. Is this an experiment? No. So 2309 is less than 10% of all U.S. citizens, and 1058 less than 10% of all Germans. One condition, 2 conditions, and now I got to check the approximately normal. And so I'm going to go over here and I'm going to say, I don't know, but I'm going to say 2309 times 0.26. And I'm going to get my little calculator and tell me what that number is. And then I'm going to say 2309 times 0.74. And I'm going to tell me what that number is. Hit me.
Do we have to calculate it, or can we just say, and put like an inequality sign and say greater than 10?
What is?
Like for 2309 times 0.26, we just put greater than 10. Or you have to put the number and then say that number is greater than 10.
I don't know if you verified it. Fair enough. It doesn't take much to go ahead and just do that. Y'all hear what he's just asking, can I just say that this is greater than 10? I'm assuming it's greater than 10, but just multiply it. You got your calculator. Fair enough. And then I got to do 15. Oh, sorry, dang it. 1058 times 0.22. And then 1058 times 0.78. And again, just figure out what those numbers are. Greater than 10. And then I love for you to say, so approx norm. You don't have to do that. I just like for you to do that. That way you know why you did it. I think you need to know why you did it, But I think you need to know why you did it, especially if they ask you, why would you do that? If it's not large enough, well, I don't know what the shape is. If I don't know what the shape is, guys, I can't find the z-score. I can't find that critical value. Let's see what they did. Independent, random samples, 2309 U.S. adults, 1058 German adults, check. 2309 is less than 10% of all U.S. adults. 1058 is less than 10% of all German adults, check. They went ahead and said NU times PU, and then gave me that number and gave me 600.34. You don't have to do this, but understand that if this was a problem somewhere, you got to tell me what N is and you got to tell me what P hat is. Somewhere, you got to tell me that. And there's where they said all are greater than or equal to 10. You don't have to put the equal sign. You don't have to put the equal sign. Any questions about those conditions? Whew. Could be a good question. You got 3 free response questions on this next test. 3. 1, 2, 3. Huh. 3 sections. Huh. Huh. Hmm. Okay, let's tell you something that I always thought was like common sense, but I want to make sure that you think it's common sense. So what does this difference actually tell me? Okay, if both endpoints are positive, okay, if they're both positive, that has to mean whatever population, let me rephrase that, I guess, whatever sample we started with, we think that population is larger than the other one. Whatever one you started with, because it's what? We did P hat 1 minus P hat 2. If that's a positive number, that must mean that this is bigger than this one. It has to be bigger. So if both endpoints are negative, we have to assume that the population of the one we did first, whichever one you did first, has to be larger than the other one. And not only does it have to be larger, guys, we kind of know how much larger it is. That question on 8.1 with the girls' shoes and the boys' shoes, and both of those numbers are positive, we have to think that the proportion of all girls have more shoes than boys. But not only do we know that they have more, we know about how many more they have. Both endpoints are positive. P1 minus P2 is positive. That means you think P1, not P hat, we're not P hat, P1 is bigger than P2, and we know how much. 0.24 to 0.36, whatever that is. P1 is bigger than P2 by somewhere between 24 and 36%. Y'all okay with that? Because they might ask you, what does this tell us? What does this tell us? What does this interval tell us? Okay. Now, let's say that both endpoints are negative. Both endpoints are negative. Then we have to think one of 2 things. P1 is smaller than P2, or P2 is bigger than P1. And I didn't mention that on this one, but we could think that also. We could say P2 is smaller than P1. So you could say that. This basically tells me 4 things right here, guys. It's not the only thing it tells me. It doesn't tell me that P1 has to be bigger than P2. I shouldn't say have to. Could be. But it also tells us that P2 is smaller. If they're both negative, then we know P1 is smaller. We know P1 is smaller, or we know P2 is bigger. And that's why I'm telling you guys, it doesn't matter which way you subtract. If I did duct tape minus freezing, if both of those are positive, if you flip-flop that, then both of them will be negative. And it's still going to tell you that the duct tape is larger. I flipped all that stuff. Duct tape's actually smaller. But. Okay, so write that down, understand it. It's very possible they could ask you, like, what does this mean? What does this tell us? What does this tell us? Okay, what does this tell us? And the only other option we have, they both be positive, they both be negative, or one of them's positive and one of them's negative. That's the only other option we have. Both positive, both negative, or one's positive and one's negative. And if one's positive and one's negative, what number has to be in the middle of that somewhere? 0. And if 0's in there, we have to think there's no difference. I don't care where it's at. If it's in there, we have to think there's no difference. 0's included in the confidence interval. We have to think there's no difference between the two populations. Don't reference the samples. There's no difference between the samples. No, there probably was a difference in the samples. There's no difference in the populations. Okay, write down what you need to from that. And I think we're pretty close to calling it quits. We're going to do a big problem. We'll call it happy, happy, joy, joy. Any questions? Questions, questions, questions? Okay, beautiful, beautiful, beautiful. Yippee! I only really have to teach like one more chapter, and then, because chapter 9's a repeat, or chapter 10's a repeat, chapter 11's a repeat, and I don't have to do a whole lot. I'm kidding. I'm kidding. Yes! I forgot my lunch this morning. My daughter just said she dropped it off. Dropped it off. It's in my driver's floorboard. Don't anybody go out there and get my lunch, though. Y'all are quiet today. Who's gone? It's because one kid's gone. It changes the whole. Amazing. I'll tell him that we noticed that. Probably need all 28 of y'all to tell him that. Pencil good? Happy, happy? Click. Click. Big problem. Big problem. Okay? Almost identical to what you're going to see Friday. Because I think I'm giving you a 2 sample. I don't remember, but I think so. Patients with lower back pain are often non-steroidal, anti-inflammatory, whatever, drugs to help ease their pain. Researchers wondered if taking Valium along with naproxen would affect the pain relief. To find out, they recruited 112 patients with severe lower back pain, randomly assigned to one of 2 treatments. Ding, 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 ding. This is now telling me what? Experiment. I don't check the 10% rule. You can write, I don't have to check the 10% rule, or you can just forget it. Okay with that? You don't have to say, I don't have to check it. There will probably be a question somewhere if AP wanted you, like, do you need to or something, but okay. After 1 week, 39 of the 57 subjects who took naproxen and Valium reported reduced lower back pain, compared to 43 out of the 55 that took the naproxen and a placebo. So these guys took naproxen and Valium. These guys took naproxen and a placebo. That way they didn't know, right? Construct and interpret. There it is. Construct and interpret. This is a full-blown problem. I got to do MCQ because I want to E. A 99% confidence interval for the difference. Guys, I told you guys, this is where I get my conclusion. The difference in the proportion of patients like these. Why is it like these? Because it was an experiment, and it really wasn't a random sample, because it wasn't a random sample of all. It was a sample of people, those with back pain, right? So I'm going to put that in my problem when I say it. Like these, who report reduced lower back pain after taking naproxen and Valium versus after taking naproxen and the placebo. Okay, here we go. Click. I've got, careful, I don't want to say I've got 2 independent SRSs, because I don't really have 2 independent SRSs. I've got 2 different or 2 independent experimental groups. I got 2 experimental groups. I don't even know if they're independent. I guess they're independent because these guys are getting one drug and these guys are getting something different. Y'all kind of okay with how you need to say this stuff? Say kind of what it is. Don't get it wrong, but I got 2, I'll go ahead and say an independent, randomly, listen to me, randomly assigned groups. How about that? Because it wasn't randomly selected, it was randomly assigned. How many were in one of them? 57 and 55. 57 that will take naproxen and Valium, and then I already forgot, 55 that will naproxen and the placebo. I don't check the 10%, but I still got to check normality. And so I can say 39, and what am I left with? 16? Oh, 18. That's why you guys have calculators. These are my successes, these are my failures. And then the other group, there were 43. Ooh, we're getting it close. Ooh, 43 and 12. If you wanted to, you might say a little bit more like this is N times P, but success, failure. Did it backwards. Success, failure. There, that one spells it right. Dyslexia, leave me alone. Greater than 10. So leave me alone. Got feelings. I'll see some stuff you guys write. Conditions. Method. 2. SAMP, prop, Z, interval. Name or formula. I'll do both because the formula I'm pretty good at. P hat, how about V minus P hat placebo plus or minus Z square root P hat V 1 minus P hat V in V plus p hat p, 1 minus p hat p in p. Whoops. Do you have to write all that? No. No. But you got to write one of those two. You got to tell me what you're going to do. And you got to tell me what p hat v is, and you got to tell me what p hat p is, and you got to tell me n1, and you got to tell me n2. You do not have to tell me z, but if you do, that really makes it look like you know what you're doing. Yes? You can use whatever you want. You can use 1s and 2s. I just kind of like to separate it a little bit to kind of help me. Right? But you guys can call it whatever you want, and you don't have to put v first. You can put p first if you want to. They don't care. However, did they tell me who would receive? Notice that they put naproxen and Valium after taking naproxen and placebo. So they did the Valium first and then the placebo. I'm probably going to do it. I want to stay consistent. Everybody okay with that? And so I'm going to just tell me what p hat v is, and I'm going to tell me what p hat p is, and I'm going to tell me what n v is, and I'm going to tell me what n p is, and because I'm a nerd, I'm going to tell you what z is. .684. 0.684. Cheating. 0.782. 0.782. How many of these cats were there? 57. 55. 2.576. Remember, that's how you need to, you can find that. You need to know how to find that. You need to know how to find that. And then we're going to do my interval. Boom, boom, boom. Let me make sure you guys can do this on your calculators. Make sure. I always assume so much. That, Riley, you, a couple others. Like I said, I do have this program that I wrote that says crit val. If you want it, you can get it. It finds the critical value. When you run it, it asks you first, is it proportions or means or quit? It's proportions because that's all we know how to do. And it asks for either confidence level. You can put in 0.95 or you can put in 9.5 or you can put in 9.9. It doesn't matter. I fixed it to where it didn't matter which one you put. The z-score is 2.576, or there it is rounded. And it's legal to have on your calculator because it does the same thing your calculator does, sort of. Okay with that? And then I got really nerdy and I said, created by Coach Mayer because he loves you and you owe him some Cheez-Its. End. That's where the 0.2576 came from. If you can get that program between now and Friday, keep it on there, whatever. I don't care. Stat, tests. Test. Z interval, nope. T interval, nope. 2 cent Z, nope. Nope, it's not 2 cent Z. It is a 2 prop Z int. I need to write that down. That's the method. I either need to write it down or the formula. And now it's going to ask you all these questions, right? How many were the first group? 37? 30? 39 out of the 55? 57. Second group? 43. That was 55, and this is 0.99. Quick question. What did I tell you about this X1, this X2? They cannot be decimals. They cannot be decimals. They can't. They will give you an error. So if they're a decimal, round it. Round it. You just calculate. Looky there. It's giving me p hat 1. It's giving me p hat 2. It's giving me n1. It's giving me n2. And that's what I think Sadia was saying. You might want to use 1s and 2s because that's what your calculator is doing. However you guys do this. It doesn't matter. And there's your interval. I got a negative and a positive. So it tells me what immediately? Zero's in the middle. So is it advantageous to give me the, what was it, an approximate volume with it? Doesn't look like it. Doesn't look like there's any difference between the two. Don't mention all that unless they ask, guys. Don't mention that stuff unless they ask. I'll say it again. Don't even mention that unless they ask. What if I do? It better be right. If you're right, you're okay. If it's wrong, they're going to ding you. Okay, I didn't write my conclusion. So there's my little interval, right? It was negative and a positive. Okay, it was a negative number and a positive number. And then we got to write my conclusion. We are, let me make it bigger so it doesn't take up the whole thing. We are 99% confident that the above interval, how about that, huh? Captures the true, dadgummit, difference. And then remember what I said, guys. I'm going to go right here and write that down. The true difference in proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium versus after taking naproxen and placebo. Use their information to write your context. They will steer you the right way always. I'm getting ready to run out of time. Put ... Make sure I got the true difference in proportions of patients like these ... If you're going to run out of time. Don't run out of time for writing context. But okay, a bunch of pencils are going, but I'm telling you guys, it's a whole lot easier to grade it when you guys do it right than when you do it wrong. It's really easy to grade it if you leave it blank. If you don't know how to do it, just leave it blank for me. But I don't think anybody's going to. Where do some students mess up on this? Pretty much forgetting to put something. Some students might put the 10% here. That's a little uh-oh. Yes, ma'am? Which way? Oh, I'm sorry. I was getting your context. Click. I think this is going to give me all my points. I can't see any reason why this would not give you, like I said, I don't know the rubric. I do know that rubric, but how many points is this worth at least? 12. 12 points. How many free response points are there? 26. Hit me.
So as long as you include P hat B equals P hat P equals and all those variable values for calculations, the only thing you can put down is the interval.
Yep. I used to make people, like I said, put these values right underneath it because that covered 2 points. It named it, plus it labeled the variables. So I'm not going to make you do it that way, but you got to get it in there. And there's no reason why I can't put right underneath that. Then I don't have to put all these equals things. Let me show you how they did it just to make sure. 2 sample Z interval for P1 minus P2. Here, they didn't say hats right here. They don't need to, right? I'm doing it for the populations. Random assigned, 10%. We don't have to check the 10%. This was an experiment. Large counts, there they check the large counts. Here they told me P1, here they told me P2. Here they just did the whole entire formula. You don't have to plug and chug into that, but you do have to get this interval. Word of caution real quick, guys. I know we're about done here. Most of the time, the free response will give it to you like that. I'm sorry, the multiple choices. Okay? Just recognize that. There's my conclusion. Many students lose credit when defining parameters in an experiment by describing the sample proportion rather than the true proportion. Don't say we're 99% confident that the true or the difference in my sample or the difference, right? Oh, here it is. Based on this interval in part A, what conclusion would you make about whether taking volume along with naproxen affects the plane? Justify your answer. Because 0 is in my confidence interval, I will say there is no difference. And then I'm going to go back. No difference in taking Valium along with naproxen in pain relief. But that's the big key number, because 0. If they were both positive, I would think I would go ahead and do that. If they were both negative, I for sure would not do it. I would do the other way, which was just the naproxen. But because 0's in there, I don't think there's a difference. What'd they say? Because the interval includes 0 as a plausible value for P1 minus P2. Again, be careful about writing stuff like this, because if you put hats in there, they're going to ding you. We don't have convincing evidence that taking Valium along with naproxen affects pain relief for patients like these. Good enough? Never suggest you believe the difference is 0, because 0's in the interval. Here's where the calculator can do it. I'm done. I'm done. Let me get that assignment to you guys. Let me